Hello and welcome to the first video in the online STEM video series. My name is Dan Fleesick and I'll be presenting these lessons and demonstrations as a supplement to anyone that's doing any kind of online STEM learning. These presentations are intended for both teachers and students to help everyone learn important STEM concepts through a combination of short lectures and fun demonstrations. So let's get started. Today's topic is pH. This stands for potential hydrogen or power of hydrogen and is a measure of the concentration of hydrogen ions in a solution. And that tells us how acidic or basic that solution is. Interesting historical side note, the actual meaning of the P in pH is disputed because the scientist who originally introduced the concept never explained it. But we do know that the H stands for hydrogen, and that's the important part. So here's a pH scale that I made. And you can see that the scale ranges from 1 to 14, with low numbers on the scale meaning acidic and high numbers on the scale meaning basic. A pH of 7, right in the middle there, is neutral. It's neither acidic nor basic. And I also put a couple of common household items on there to give you an idea of what acids and bases you might actually find. So things like coffee, tomato juice, or battery acid are on the acidic side of the scale, while things like baking soda, ammonia, bleach, generally cleaners, are on the basic side. But how do we test pH? Well, there's several different ways, and I'm going to use these pH indicator strips. Now what these are, they come in like a little matchbook, and they change colors based on the pH of the solution. So you can see the low numbers are the reds and oranges, neutrals are around greens, and then it goes into blues and purples as you get higher up, which kind of corresponds to my arrows here. That's a pretty common color scheme for pH indicators. Okay, now that we have a general understanding of pH, let's test a few liquids around the lab and see what we come up with. Now before we do anything in the lab, we need to make sure that we're doing it safely. So I've got my lab coat on, my gloves, and my chemical splash goggles, so I'm ready to go. Now I want to remind everyone too that don't try any of the things you see in these videos at home unless I explicitly tell you that it's alright to do so. Here in these beakers I have two clear solutions. The one on the left is hydrochloric acid with the symbol HCl, and the one on the right is sodium hydroxide with the symbol NaOH. Both of them are the same concentration, 1 molar, and both are the same volume, 20 milliliters. Now before we test their pH, let's make a hypothesis. Which beaker do you think will be acidic, and which one do you think will be basic? Take a minute to pause the video and think about your hypothesis. All set? Let's test. We'll start with the one on the left first. We get a very deep red color. So if we compare that to our chart here, that looks like a 1 to me, way at the bottom of the scale. So as you might have guessed, hydrochloric acid is in fact acidic. So now let's test the other one. And we get a beautiful blue color. And comparing that to the scale, that's way up on a 13, maybe even a 14. So sodium hydroxide is a very strong base, and so you get a high number on the scale. The type of water I use to make solutions in chemistry is called distilled water, and I have a sample of it here in this little bottle. Distilled water is nice because it contains no impurities, it's just H2O. So what do you think the pH of distilled water would be? I'll give you a second to think about that. All right, let's go ahead and test. So I'll just put a couple of drops directly onto the pH strip. And we get, looks like a light green color, so let's compare that to the chart. That looks a little bit too green for a 6, so I think that's a 7, which is what it should be. Water should be neutral. So we know that distilled water has a pH of 7, right in the middle. But I have a bunch of different sources of water around the house that I'm kind of curious about testing. Now, it's important to not mix chemistry equipment with anything else, especially things in the kitchen. So what I'm going to use is just a plastic disposable cup to collect my samples and then use that to dispense into each one of these. So let's get a sample from the bathroom sink. Filtered water from the fridge. And some bottled spring water. All right, here's our 3 samples. Now go ahead and make your hypothesis. What pH do you think each of these will be? All right, let's find out. First, the bathroom sink. Looks about the same as the distilled water. I'd say a 7 on that one. Now the fridge. Yeah, that also looks like a 7, so that's good. And then finally the spring water. Yep, they all look the same to me. So that's good. You don't want your water to be too acidic or too basic. Finally, let's test some other household liquids. Here I've collected some strawberry lemonade, soda, and soapy water. And I collected this with the same disposable cup method as I did with the water, just to make sure that there's no contamination. So what pH do you think each one of these liquids will be? Take a minute to pause the video and think about your hypothesis. All right, let's test. We'll start with the strawberry lemonade. We get a nice orange color. That looks to be about a 4 to me. So the lemonade is definitely acidic. Next, let's try the soda. That also looks a little orange, maybe not quite as orange as the last one. I think I'll call that one a 5. And then finally, the soapy water. We get a very dark green with looks like spots of blue on it, which is kind of interesting. So I think the base color is a 9, but since we've got some spots of blue on there, maybe we'll call it a 9.5. So the results of our test shows that lemonade is pretty acidic, soda is a little bit acidic, and soapy water is a little basic. Now this makes sense. We know that lemons are sour, and that sour taste usually comes from acidic foods. Sodas have phosphoric acid as one of their main ingredients, and so the overall soda shows up as being acidic. Bases usually make great cleaners and soaps, and so you can usually tell if something is a base because it feels slippery, like soap does. So now back to my pH scale, and I've added in the results of all of our tests. You see the acids were hydrochloric acid, lemonade, and soda. All the waters came in about neutral. And we had soapy water was on the base side, and then sodium hydroxide was up at the top. So that concludes this video on pH. I hope you enjoyed it and learned something new. Thank you very much, and we'll see you next time.